The Enlist weed control system utilizes the Colex-D technology. Colex-D technology is found in both Enlist 1 and Enlist Duo. The two main features of Colex-D technology are a 90% reduction in volatility compared to traditional forms of 2,4-D, and when paired with the correct nozzle, we also see a 90% reduction in physical drift potential. The 90% reduction in volatility comes from a proprietary formulation called 2,4-D choline that is found in no other herbicide on the market. 2,4-D choline is extremely stable underneath multiple environments of humidity and high temperatures, and we have seen it is essentially a non-volatile form of 2,4-D. The 90% reduction in physical drift comes when we are paired with the correct nozzle, and we use the Colex-D technology. The best way to show this is to walk through a brief history of nozzle technology and see how that has impacted driftable fines. The first nozzle that was created were the flat fan nozzles way back in the 40s. The flat fan nozzle does two things, just like all nozzles do. They meter the herbicide flow and then evenly distribute it across a land area. So those two jobs, the flat fan nozzle uses one orifice for both jobs. You can see the flat fan nozzle does a great job of distributing the herbicide. However, there is no reduction in physical drift. We have excellent coverage, but we produce a lot of these driftable fines, these very small particles that are prone to move in the wind. The first nozzles that were used to reduce physical drift potential were the T-Jet drift guard nozzles. The first technology introduced was a pre-orifice. So the pre-orifice is an orifice at the top of the nozzle that meters the flow, and then you use the bottom orifice to distribute it. So we take those two jobs of metering and distribution and we split them apart. Inside the drift guard nozzle, using that pre-orifice, we'll see a slight drop in pressure between the pre-orifice and the exit orifice, and anytime we drop pressure or change velocity, lower velocity, we're going to see a reduction in physical drift potential. So the drift guard nozzle compared to the flat fan nozzle, you see we see a good reduction in physical drift potential compared to the flat fan, but we also see that we're still producing a large amount of driftable fines. The next iteration, or the next nozzle technology, were the turbo T-Jets. The turbo T-Jet, also affectionately referred to as the hammerhead nozzle, because of its hammer shape. That nozzle uses two technologies. One is a pre-orifice that meters the flow. It also incorporates a turbulation chamber, which lets the velocity be reduced as well as the pressure. And to further reduce the velocity, it uses two 90-degree turns in the flow path, which reduce your velocity. These nozzles also have the advantage of being able to run at lower pressures than your standard flat fan or drift guard nozzle. So you can see a good reduction in driftable fines, but with also you can run into, at low pressures, run into some spray coverage issues. So the next iteration in nozzle technology were these long nozzles. These are the traditional air induction nozzles. These nozzles use a pre-orifice to meter the flow, and they also bring air into the spray solution stream through the Venturi effect. So you have an aeration of that spray solution. If you could take a microscopic look at these droplets, you'll find that they contain air bubbles, and that's what makes them larger than the normal droplets. These nozzles have a great reduction in physical drift potential, but and they produce an extremely coarse droplet size. But as you can see, you don't have near the coverage that you would have with your flat fans or drift guards or turbo Ts. These nozzles are great for systemic products. However, for contact herbicides such as glufosinate or some of the other products that we might use, these nozzles, you can see a reduced amount of control because of the lower amount of coverage. So really, choosing nozzles, we're trying to balance drift reduction and spray coverage. So one of the nozzles that is preferred for the Enlist weed control system are the TDXLs from Greenleaf, or even something like the AIXR from TJet. These nozzles incorporate 3 different drift reduction technologies. So they're going to have the pre-orifice that helps meter the solution. They're going to have a turbulation chamber to help the pressure drop and slow the velocity. And they're also going to incorporate air induction, which increases your droplet size. These nozzles also have the advantage of being able to run at lower pressures, and so you'll see a great spray coverage, medium droplet size, excellent drift control properties of these nozzles. So comparing something like a TDXL to your standard flat fan, you can really see a difference in the amount of driftable fines that are produced by these TDXL nozzles. So we'll see a 45% reduction in driftable fines from the TDXL compared to the flat fan. The next thing that we can do is the formulation influences the jet sheet, or how the spray droplets are formed. The jet sheet is this area of undifferentiated spray directly below the nozzle. So formulations impact that area of undifferentiated spray. High surfactant loaded products like some of our glufosinate and glyphosate formulations can actually increase the size of that jet sheet and increase the drift potential of your spray solution. So in my auxiliary tank here, I've mixed up a 32 ounce per acre application of glufosinate, and what we'll do is it gets introduced into the system and flushes out the water that we're using right now. You should be able to see that jet sheet increase, as well as see an increase in driftable fines. So as you see the jet sheet increase as it goes across, you'll see the increase in driftable fines, and that is simply an impact of formulation. So anything that impacts the surface tension of the water or the spray solution is going to impact that jet sheet. So the Enlist weed control system, utilizing the Colex-D technology, really shrinks that jet sheet, reduces the amount of energy that's required to break these into droplets, and therefore gives us a more uniform spray pattern with lower amounts of driftable fines. So what I'm going to do is introduce about something equivalent to about 32 ounces per acre of Enlist 1. So this would simulate an Enlist 1 plus glufosinate tank mix. Just a little bit of agitation into the spray tank. And as this spray solution works its way across, what you should be able to see is that jet sheet dramatically begin to shrink, and the driftable fines dramatically reduced compared to the shot of glufosinate alone. So a great reduction in physical drift potential by using the drift control measures found inside the formulation of Enlist 1. With Enlist 1 and Enlist Duo, we see a 90% reduction in volatility, as well as, when they're paired with the correct nozzle, a 90% reduction in physical drift potential compared to traditional forms of 2,4-D.